All right, so remember I said we were going a little bit out of order this unit. This is linear functions day 5. So we did day 8 yesterday. We're back to day 5 today. And it says the table below shows us the warm-up. So this is kind of from a while ago. It has nothing to do with 3x3 systems. You'll need a calculator for it, so if your calculator's not out, grab that. It says the table below shows the percent of the adult population that married before age 25 in several different years since 1970. Using the year as the independent variable, so that's x, with x equals 0 representing the year 1970, find the linear regression equation. Round the regression coefficients to the nearest hundredth. So before we read the second part, let's just get that done. Now this is a little trick that the Regents seems to like to pull every once in a while. Using the year as the independent variable with x equals 0 representing the year 1970. So that means this, if 0 is 1970, what's 1971? This would be 1. 1976 would be 6. 1980 would be 10, 14. Oops, shouldn't say 84 twice there. This should have been 1989. Sorry. So that would have been 19. 1993 would be 23 years since 1970. This would be 27 years, and this would be 30. So when you do L1, remember this is a regression. This is when we do L1, L2. We're going to have to put those numbers, not the 1970 numbers, into L1. Okay, so go to your calculator. Remember how to do this. How do I get to the L's? I go to Stat, Edit, and if you want to clear out if there's any numbers in here already, remember the way we clear them out is by going up here, hitting Clear and Enter, not Delete. So put in all these numbers, so 1, 6, 10, 14, 19, 23, 27, and 30. And then in L2, put your corresponding percents, so 42.4, and 37.4, 37.1, 34.1, 32.1, 28.8, 25.7, and 25.5. So clearly the percentage of people getting married before 25 has a downward trend. Okay, so hopefully we got all those into L1 and L2, and then I want to find the linear regression equation. Where do I go for that? Remember, I go Stat, Calc, LinReg, so choice 4. Then if you got a new calculator, you should have X list as L1, Y list as L2. Remember, make sure there's nothing in freq list. That should be empty. You don't need anything in store regression equation either. Just go right down to calculate. And there's our equation. Okay, so work-wise, what do you need to show? You need to show your calculator steps. So I need to see Stat, Calc, LinReg. It'll help for partial credit. And I put in L1 and L2. Watch your rounding. Regression coefficients to the nearest hundredth, so that's 2 decimal places. So y equals negative 0.58x plus 42.31, that'll be. So make sure you have your y equals. Remember, that's an easy point to lose. Negative 0.58x plus 42.31. So that's my linear regression equation. That's the first part. Then it says, using the equation found above, estimate the percent of the adult population in the year 2020 that will marry before age 25 and round to the nearest tenth of a percent. Is this an example of interpolation or extrapolation? Okay, so I need the year 2020. What would x be if it's 2020? Well, it's years since 1970. How many years since 1970 is 2020? It's 50. So we're looking for an x value or a y value? Well, it says estimate the percent, that's the y value, when the year is 2020. So if you're using I want when thing, I want a y value, the percent. And when do I want it? I want it when the x value is 50. So plug that into your equation. Y equals negative 0.58 times 50 plus 42.31. Definitely going to have to use the calculator for that. So, can't get it all on the same screen here. It's negative 0.58 times 50 plus 42.31. 13.31. Now watch the rounding again. It said nearest tenth of a percent. So 13.3%. So according to this model, only 13.3% of people will marry before the age of 25 in the year 2020. Is this an example of interpolation or extrapolation? Remember, it's extrapolation because that x value of 50 that we used is outside of the range of values that were given. So that means it's not quite as reliable as if it was some value that was between 1 and 30. Okay, so that's just a quick review of regressions that we did last week. Hopefully you have today's notes in front of you. It looks like this. Inverses of linear, oh, sorry, I didn't show you the random fact of the day. Is that on the sheet? Let's see here. Where am I? I got too many windows. I think it's this one. Random fact of the day, vultures can fly for 6 hours without flapping their wings. So keep that in mind. Okay, here's today's notes. Inverses of linear functions. So I went out of order because this day is actually one of the easier days. We've done inverses before. So this should look a little familiar. Now, last time we did inverses, I said anytime you see that word in math, you want to think of one phrase. And what is it? Not opposite. Inverses means switch x and y. Anytime you see the word inverse, you got to think switch x and y. Okay, so now it says recall that functions have inverses that are also functions if they are what? Well, remember, if you switch x and y, what makes something a function? No repeating x values. So if you're going to switch x and y, you can't have repeating y values either, because when you switch it, those will become repeating x values. So if it has no repeating y values and no repeating x values, we call those types of functions one-to-one. So that's when they pass the horizontal and the vertical line test. Remember what one-to-one meant? So it says with the exception of horizontal lines, all linear functions have this property and thus have inverses that are also functions. Now horizontal lines are the one difference. Horizontal line would not be one-to-one because it would obviously fail a horizontal line test. Okay, come back to that later. Example 1 says, on the grid below, the linear function y equals 2x minus 4 is graphed along with the line y equals x. How can you quickly tell that y equals 2x minus 4 is a one-to-one function? How do you know that this line here is one-to-one looking at its graph? It passes the horizontal and vertical line test. Right. So it passes the vertical line test and the horizontal line test. Part B says graph the inverse of y equals 2x minus 4 on the same grid. Recall that this is easily done by switching the x and y coordinates. Remember, switch x and y of the original line. So let's look at the original x and y values they give us. Look at this first point down here. That'd be negative 1, 1, 2, 3, 4, 5, negative 1, negative 6. And then I've got 0, 1, 2, 3, 4, so 0, negative 4. I've got 1, negative 2. I've got 2, 0. And I could keep going, but really I only needed 2 points to make a line, so that's more than enough. Remember, I switch x and y if I want the inverse. So now instead of negative 1, negative 6, I have negative 6, negative 1. Instead of 0, negative 4, I have negative 4, 0. Negative 2, 1. 0, 2. Okay, then I can plot those. So -6, -1, 1, 2, 3, 4, 5, 6, -1 right there. -4, 0. -2, 1, 0, 2. And carefully connect those points the best you can. Should look something like that. So that's the inverse. And it says, what can be said about the graphs of y equals 2x minus 4 and its inverse with respect to the line y equals x? We talked about this in the past too. Why is that line y equals x even there? What is that showing with the inverse in its original function? The original function has been reflected over that line. So you can say they are reflected over the line y equals x. Remember we talked about that. You've learned that in geometry. If you want to reflect over the line y equals x in geometry last year, you flip the x and y's. Okay, next up it says find the equation of the inverse in y equals mx plus b form. So the inverse started as y equals 2x minus 4. That's what the original equation was. When I'm doing the inverse, I got to first switch x and y. So x equals 2y minus 4. What's my goal after I switch x and y? I want to solve for y. So get y alone. So I have to add 4. Now some of you had problems with this on the last test. X plus 4, there's nothing I can do. I just have to leave it as x plus 4. So x plus 4 equals 2y. Divide by 2. And if it wants in y equals mx plus b form, I got to have a number in front of x. So right now this is like 1, so it'd be 1/2 x plus, so I divided that by 2. I also have to divide this by 2. So 4 divided by 2 is 2, equals y. So there's my mx plus b. Y equals 1/2 x plus 2. That should confirm with what we have on the graph. It's got a y-intercept of 2. And the slope is rise 1 over 2. So that works. Sometimes they might want the equation in y equals x plus b over a form. That basically just means we're allowed to stop at this step. So I would still have to start with y equals 2x minus 4. I still have to switch x and y, so x equals 2y minus 4. X plus 4 equals 2y. Divide by 2, divide by 2. That's the form they're talking about. So y equals x plus 4 all over 2. And that's a totally legit equation for the inverse. It just isn't that mx plus b, so it'd be harder to see as a line. Okay, so hopefully that seems a little familiar. Here's the next page. For each of the following examples, we're going to graph the linear function. Then we're going to graph the line y equals x to show that reflective property. Then we're going to graph the inverse function. We're going to write the equation of the inverse. Okay, so first step is to graph. So y equals 5x minus 7. What's the slope? 5. What's the y-intercept? -7. So we plot -7, 1, 2, 3, 4, 5, 6, 7 right here. And then go up 5 over 1. Up 5 over 1. That's probably enough. Do the best you can to draw a straight line through those points. And it's listed as y, but I'm going to call that f of x just to denote original function. Now I got to graph the line y equals x. So remember that's just this diagonal line going through the origin. And eventually when I graph the inverse, I should have that reflective property showing. Now if I want to graph the inverse and I don't have an equation for it, the best way would be to make tables. So I'm just going to use some of those original points. I had 0, -7. I had 1, -2 it looks like. And I had 2, 3. When I want a table for the inverse, what do? I switch x and y, so -7, 0, negative 2, 1, and 3, 2. Plot those. Negative 7, 0, negative 2, 1, and 1, 2, 3, 2. You should see that reflection over the line y equals x. Now, how do I label it for an inverse? Remember inverse notation? F to the negative 1 power, it looks like. That means f inverse of x. And you can see the reflection happening over that line. So we're in good shape. Last step is to write an equation for the inverse. So if I'm starting with y equals 5x minus 7, what's my first step? Switch x and y. So x equals 5y minus 7. Then what's my goal? Get y alone. So add the 7. X plus 7 equals 5y. Divide by 5. And I end up with y equals, remember we're dividing both of these pieces by 5, 1/5 x plus 7/5. Now I usually get it into that mx plus b looking form just so it looks more like a line. If you left it at that x plus 7 all divided by 5, it didn't specify how to leave it, so technically that's correct, and you'd be fine. Okay, let's do one more of those real quick. Hopefully that wasn't too bad. Here's the second one, y equals 2/3 x plus 4. First we want to graph it. What do I need in order to graph it? I need the slope, which is 2/3. I need the y-intercept, which is 4. So plot 4. And then we're going to go up 2 over 3, up 2 over 3. That should be enough to get a decent looking line through here. That's my original, so I'm going to just label that f, or f of x. Next, we graph that y equals x line. Do that in red, so it'll look like this. And if I want an equation for the, or a graph of the inverse, I'm going to make a table for my original. Use those points I plotted, so 0, 4, and looks like 3, 6, and 6, 8. The inverse will be 4, 0, 6, 3, and 8, 6, because inverse means what? Switch x and y. Not opposite. Just applying these points. Connect those dots. And it does look like a reflection, so we're in good shape again. That's f inverse of x. Remember, anytime you've got more than one graph, you've got a label. So I've got all these labels here. And then find an equation for the inverse. So I'm starting with y equals 2/3 x plus 4. Switch x and y. X equals 2/3 y plus 4. And I got to solve for y. So what's my first step? Subtract the 4 over. X minus 4 equals 2/3 y. How do I get rid of that 2/3? You can either multiply by 3 halves, or start by multiplying by 3, which becomes 3x minus 12 equals 2y, because those cancel, and then divide by 2. So divide everything by 2, I get 3 halves x minus 6 equals y. Okay. Hopefully no questions. Makes sense? Okay. Now these last few questions, you got to do a little thinking about. So first it says, what's the y-intercept of the inverse of y equals 3/5 x minus 9? Well, there's a couple ways we could go about this. So if I want to find the y-intercept, this is a little bit old review too. Remember how to find any y-intercept ever? The way you find any y-intercept ever is you set x equal to 0. We talked about that in the functions unit. So one thing I could do if I want the y-intercept of the inverse, I could find the inverse and then pick out the y-intercept. So let's do that. Find the inverse. What's my first step? Switch x and y. X equals 3/5 y minus 9. Solve for y. X plus 9 equals 3/5 y. And to deal with that, getting rid of that 3/5, we can multiply by 5/3. I prefer to multiply by 5 first. So 5x plus 45 equals 3y. And then divide by 3. So I get 5/3 x. 45 divided by 3 is plus 15 equals y. Now I said the way we find any y-intercept ever is to set x equal to 0. And you can see if I plug in 0 real quick here, what am I going to get? Well, this is going to go away, and I'm going to be left with 15. But this is also mx plus b form, so it should make sense that 15b is the y-intercept. So the y-intercept is 15. Now, if that totally made sense to you, good, do it that way. There's a sneaky, fast way to do it, too, that some of you maybe have thought of. If I want the y-intercept of the inverse, what would that have been in the original function? So we know a y-intercept is when x equals 0. We don't know what that is. But on the original function, because that's what I'm given here, instead of x being 0, that point would have corresponded to y being 0. So I could take original function and set y equal to 0 in that original function. And that should also give me the y-intercept of the inverse. So if I do that, 0 equals 3/5 x minus 9, and solve it, I'd have to add 9. So 9 equals 3/5 x, multiply by 5, 45 equals 3x, divide by 3, get 15 equals x. So the y-intercept, as we saw a minute ago, is indeed 15. Now that kind of takes a lot of really thinking. You've got to really understand what an inverse is and what a y-intercept is in order to do it that way. So if that confused you at all, erase it from your memory, do it that way. But there's two ways to get to that answer. Okay, now on the last page there's some multiple choice questions. And even though this whole concept of inverse isn't that tricky, that can mess people up. So let's look at this last page. So sometimes we were asked to work with linear functions in their point-slope form. So we've done everything with y-intercepts today. Remember, point-slope is y minus y1 equals m times x minus x1. The method of finding the inverse and plotting it, though, do not change just because the linear equation is written in a different form. So example 4. Which of the following would be an equation for the inverse of y plus 6 equals 4 times x minus 2? You got to kind of work backwards. This is the original function. What's the slope of the original function? Remember, the slope is right here. That's 4 over 1. 4. They're also giving you a point. What point is this giving you in the original function? Remember, this is x1 and this is y1, but also remember that the negatives are built into the equation up here. So the actual original point would have been 2, negative 6. Now in the inverse, what would the new point on the inverse be? Switch x and y, so it would be negative 6, 2. Now what about the slope? Slope's a little tricky. What's the original equation? How do you normally find a slope? You do change in y over change in x. So what's going to happen when I take the inverse to the slope? Well, what does inverse mean? Inverse means switch x and y. So if these get flip-flopped, the slope of the inverse isn't going to be 4 over 1, it's going to be 1 over 4. And it becomes from that property of switching x and y again. So you can remember, slope of inverse is reciprocal, not the negative reciprocal, just reciprocal of original slope. And again, the reason why that happens is because we're switching x and y. So it should make sense that the x's and y's flip the slope as well. Okay, so put that all together. Now my equation would be y minus y1, which would be 2, equals my new slope, 1/4, x minus x1 minus -6 would be plus 6. And that looks like choice 1 to me. So if you look at it, ruling it out, if you know enough to switch the x and y for the points, x1, y1, these two were out right away. Didn't have the right x1 and y1. The only difference between 1 and 2 were the slopes, and again, it's not the negative reciprocal. Perpendicular is negative reciprocal. It's just the reciprocal if you switch x and y. Okay, this next one. Which of the following points lies on the graph the inverse of y minus 8 equals 5x plus 2? Think about that one for a second. Which point would lie on the inverse? Think about what point you know would lie on the original graph. And then flip x and y. What do you get? Well, this is x1, y1, right? With the negatives built in. So the original equation would have been -2, 8. When I switch x and y, my inverse would have the point 8, -2. I literally just switched x and y. So that's also choice 1. Okay, last one. Which of the following linear functions would not have an inverse that's also a function? Explain how you arrived at your choice. All right, well, y equals x. Looks like that. Y equals 2. Looks like that. 2y equals x, that's a little tricky maybe. Divide by 2. You get y equals 1/2 x. So that's a slope of 1/2 going through the origin. Looks pretty similar to choice 1, except a little less steep. And then y equals 5x minus 1. Go through -1 with a slope of 5. That'd be pretty steep, something like that. So which of those ones would not have an inverse that's also a function? Remember what we said at the very beginning of class. When you switch x and y, in order to be a function, you've got to pass the vertical line test. So if it's got to pass the vertical line test after we switch x and y, it's also got to pass the horizontal line test. It's got to be 1-to-1. So only one of these functions is not 1-to-1, and that's choice 2. So to explain your choice, it fails the horizontal line test, so not 1-to-1. If you switch x and y, what would the inverse be? Well, if it started as y equals 2, the inverse would be, instead of y equals 2, would be x equals 2. Is x equals 2 a function? No, it fails the vertical line test. Okay. Hopefully that wasn't too difficult. A lot of that should have been review. Your homework's a worksheet. Check your answers on the blue answer key. Remember, it's day 5 you're looking at on the answer key. So go back and look at day 5. Good luck.